We'll study object reference variables in this video. Let's look at this particular object reference declaration. This class name could be, for example, string. This is a class in Java, and your object reference var could be str. What you're doing is you're declaring a string reference. This string reference has the name str, which is also a variable. Inside the computer memory, we talked about this before. There's a section for heap. There's another section for stack. There's other sections for example, text, BSS, so on and so forth. So this whole portion for stack is not that big, whereas the section for heap is relatively large compared to all the other ones. This is your COM memory space. What happens when you declare a class variable? It turns out that this str sits in the stack. This stack is also used for storing primitive data types like integer, chart, doubles, etc., including reference variables. Just to give you a little more information, this stack memory is managed in a last in, first out, LIFO order. It automatically allocates and deallocate memory as functions are called or variables are declared, making it very efficient. An example of a circle object reference variable, when declared, also sits in here. This means that there is a little bit of memory spaces here, reserved, one for str and the other one for my circle. Let's talk about reference. This notion of reference is akin to what we call pointer in C or C++. Pointer is a data type that stores someone else's memory address. In Java, there's no pointer, but we call them reference. In C++, the difference between reference and pointers is pretty subtle, but for the sake of brevity in Java, know that a reference variable stores memory address. That's probably the easiest you can think of. Basically, object reference variables are fundamental to how Java handles objects and their interactions. These variables provide a way to access an object stored in the computer's memory, such as heap or stack. In Java, when you create an object, the actual object is stored in either of these memory spaces, and the reference to the object is stored in a variable. Since we're dealing with reference, which is akin to pointer, which stores someone else's memory address, this reference literally points to the memory address of something. By declaring your class name object reference, such as in this fashion, circles my circle, this my circle is not really pointing to anything, and it has a default value of null. We'll look at this a little more in the next slide. To give clarity, this assignment operator enables the assignment of this new object's memory address to be stored inside this reference variable, which stores a memory address. Let's look at this new. Inside your computer memory space where you have heap, this new dynamically allocates a memory space. This is what we call dynamic allocation. A copy of this class name, which is circle here, gets created, let's say here. This location has a memory address, let's say 0 times FA. This 0 times FA address is returned by this new operator in C++, in Java, or any object-oriented programming language that has new operator, back to this reference variable. By extension, circle my circle equals new circle. First of all, on the right side, this portion creates a dynamically allocated space with a memory address, and this new returns that memory address back, which is FA, 0 times FA. Let's use this example. And my circle then stores the memory address 0 times FA. And because my circle does not directly point to this location, only storing its memory address, we call this my circle a reference object. This is a very important concept in Java, where references are being manipulated at runtime. This variable does not contain the object itself, but rather a reference or pointer to the object. This is how we declare and create objects. Earlier, we said my circle, just by its declaration, circle, my circle, is actually located in a different section of your memory space called stack. So what you have here is my circle sits in stack, but this my circle reference stores the memory address of this newly created circle object in heap. This is the premise behind dynamic memory allocations and object references as they relate to each other. And this is also how dynamic object is born in Java. A question comes to mind, how is this important in programming? In Java, passing objects to methods is such an important aspect of object-to-object interaction. Namely, when you pass an object to a method, Java passes the reference by value. The method gets a copy of the reference instead of the object itself, making modifications to it inside the method, eventually affecting the original object, but not the reference itself. This allows developers to manage and manipulate objects efficiently, leveraging Java's powerful memory management and object-oriented capabilities. Please make sure that you understand the use of reference objects in Java and how this works, because this is such an important topic to understand in Java.